Welcome everyone, and thank you for participating in this webinar, SDC SRC, Conditioning and Quantifying Seismic Data for Advanced Reservoir Characterization Studies. My name is Arne Nordborg, and I'm the Global Business Development Manager in Cegal. And together with Gaston Bajarano, the product owner, we are going to give you a short overview of one of our Petrel plugins, SRC. I hope you are doing well despite the circumstances. Working from home, it's certainly a big difference from all of us being in this situation. From our point of view, we are planning now to give a 30-minute webinar. Recording will be sent out afterwards to our YouTube channels, and we hope that this will be an exciting little webinar for you guys. We have a Q&A session at the end. There is a chat box in the GoToWebinar, so please feel free to add questions to during the presentation, and we will then divert to that towards the end. A brief introduction to Cegal is that we started back in 2000 as a more commodity IT company, and have since then, at the start 20 years ago, evolved into a specialist in cloud and software for the oil and gas business. Especially the software part has that we will focus on today was moved strongly forward when Blueback Reservoir was acquired in 2014 into the Cegal family. With this acquisition, we suddenly had a suite of different products for the oil and gas business with a strong focus on the Petrel plugins. Today, we serve more than 13,500 users worldwide. We are also proud to be more than 420 employees around the world. As you can see from the map, we are on the 24/7 support service with our head office in Stavanger. We also have a small office in Oslo and the UK, and as you can see, westwards toward Calgary and Houston, and eastwards to Dubai, and finally we opened an office in Kuala Lumpur this year to support our Southeast Asian clients better. If you look at Cegal as a company, we have three different areas we focus on. Everything around IT and D&D software, delivering the complete solution with the IT solution, cloud solution called GeoCloud, together with our software, but also a strong consultancy group with geoscience, software development, data management, and also lately we have built up a business consulting group, which has been quite interesting to follow during these periods now, and how we can support clients on how to continue working. I now give the word to my colleague Gaston, who will give a presentation on the SRC software.
Yes, thank you very much, Arne. Good morning, Americas, and good day, everyone. This is the second webinar we're doing in the day. The early one was 8 a.m. in the morning, European time. As Arne mentioned, it's sort of interesting, difficult times for everyone. Many of us working from home. So yes, this is a series of presentations we are doing to discuss and talk about our solutions. This day, I'm just showing some of the wider view on our you on difficult and advanced reservoir characterization studies. So the next slide you see is actually something we did because we got lots of questions from our users in terms of a workflow, and that's it. That's an answer to that. That's a general representation of a workflow in the SRC tool and what you could do with it. So you start with the conditioning of angle stacks. At this point, also a comment, we don't deal with pre-stack gathers as such, but with partial angle stacks. So it's a very important aspect at the beginning to condition the stacks, then move on into other important aspects of the workflow. Then at the end, you may have different destinations from this workflow. One would be, for example, AVO classification, but another one, if you have thin reservoirs to look at, then the seismic net pay is the one you would be looking for, or ultimately, and that's a separate module, our flagship inversion tool, ODC. So let me now then go and dive into some of the aspects of this workflow. In the bottom, I've put a link here that I will refer to all the time. We have been broadcasting several other presentations by my colleagues in the UK, and they have been elaborating in more detail many aspects of this workflow. So I'm inviting you to just go to our YouTube channel and look at those presentations. So conditioning of angle stack, that's something you want to do and you need to do before moving on into other aspects of this larger workflow. The reason is that you need to understand and also try to get your partial angle stacks as close as possible to zero phase. You need to correct the effects from losing or changing this spectral distribution of your data due to the offset. And in some cases, do some corrections for the time alignment. And finally, try to make some balancing of the amplitudes, comparing or using expected well reflectivity response. And the nice thing about this tool, it is highly interactive. Everything is, you get a visual response of the operations you do while you are working on your data. Everything is kept in the virtual mode, including a part of it that already displays some AVO crossplots without going into the detail of a dedicated AVO tool in the same SRC module. So just to make an example, I'm switching now over to Petrel, and well, I'm running here my SRC, and I'm having here 3 partial angle stacks. 3 is just for this example, but we can obviously use more partial angle stacks in an application. So for the example of this, we have a near, mid, and far, and we have a window like this, which is a Blueback gather window, in that every single inline crossline in terms of geometry for the middle and the near, the middle, and the far angle stacks are displayed as a single place, but with each tree traces one close to the other. So this way you can display and compare immediately the effects of doing, for example, spectral balancing. In spectral balancing, you are calculating the effects of the loss of the changes of the frequency content with the offset, as you can see here, and then you can say, okay, I will correct for those. So now that has been already applied, and I turn it off so you see the changes here. Have a look at, especially on the far trace, when I apply this process here, then this is corrected, and then you see how this dramatically changes. Finally, I will apply the correction in terms of time adjustment, and again, this is going to be adjusted using the parameters I'm selecting. So the point is, this is highly interactive, and I'm using this the virtual attributes in the Petrel world. So all of it is completely and tightly integrated in the Petrel world. All our apps are done like this. We're not compromising anything here, meaning there's nothing we keep outside. There's no API to transfer data back and forth. Everything is happening inside this the Petrel world. So back to the PowerPoint world, then moving on into our workflow, the next step would be to calculate the intercept. So once you have done your corrections, your conditioning, then you're ready to move on and then calculate intercept and gradient. And there is several methods available in the tool to do so. Again, you can still keep everything in a sort of virtual mode if you want, or obviously, if you prefer, you can go and realize that right away to disk. This is all the well-known approximations out of the Zurbriggs equations, and this is the methods that we use and support at this stage. So this gives us then the results of having intercept and gradient. So at that stage, we could go now and say, for example, we are interested in AVO classification, which is where we would go, for example, next. And then we have a tool that inside the SRC app that deals with the AVO classification and allows you to understand the AVO effects and shade areas and define ellipses in different depths in the seismic. And again, it's highly interactive. So if you're interested in getting more details, again, I remind you to go to our channel. There you can see some of the what has been broadcasted a few days ago, specifically, for example, on the AVO classification tool. So next and quite important step would be, for example, to go and do color inversion. So then out of the, especially if we're moving on into the other branch of the workflow, here you would color invert your intercept and your gradient. And also that's quite an interactive tool where you go and calculate, extract the operator that will color invert your seismic. So we can use several wells as input, compute the trend out of the reflectivity, and then match this trend together with the computed frequency content of the seismic. And the nice thing about this as well is there is options to fine-tune the operator specifically in terms of frequency content, which is very important, especially in the lower parts of the frequency spectrum, because there is where a lot of energy and information is kept. So having to pay good attention in these areas is crucial. So all these visual plots and tools allow you to estimate the goodness, the quality of the operator you are applying. And while you're doing this, it is possible to visualize the results as a way. So here's an example where we would, that's the input, and on the left-hand side is the color inverted result as it's been done before. Then you commit the results to a larger volume, for example, where it can take some time. So all this is kept in a highly interactive way. So after that, this would bring us to have both relative acoustic impedance and relative gradient impedance, and then we would be ready to go to the coordinate rotations, which are more known into the this extended elastic impedance method. And the idea behind this is using the acoustic impedance and the gradient impedance to cross plot and to use that to discriminate between phases. You color code the cross plot using the phases, and then you can play with the projection of the chi angle. So I'm just show this briefly in Petrel. This is one of the more interactive or interesting workflows here. Here is where you see all the components, the apps belonging to the seismic reservoir characterization. And here now we are looking at the extended elastic impedance angle analysis. So I'm comparing, for example, in this case, in the log correlation, a gamma ray log during these calculations. And so you see the red and the black curves. So this one would be my EEI, and this is in the case of the chi 50. And as I'm now projecting to this axis, then I see the difference in the histograms. It's also color coded in this case also by the phases. So you see it's a sort of challenging example I have, but then by doing this projection, the idea is to be able to separate any type of lithophases that might be inside my seismic information. So in this case, we might be talking about a lithology cube and a fluid cube, or sand versus shale cube. So by producing this type of extended elastic impedance volumes, later on, we can use this as input for other processes, as we will see. So back to my presentation in this workflow. So once we've done these coordinate rotations, then we are ready to have now the relative elastic impedance in place. So then we can calculate, and we have an idea as well of which type of chi angle would also correspond to the seismic. And so we have this is the so-called EEI volume tool. And so based on this same principle, now we are turning intercept and gradient, could be reflectivities directly, or as I showed before, color inverted relative impedances into this EEI seismic attribute. So this is also done in an interactive way, and you can automatically extract the amplitude values of a reference surface, and then compare them, for example, to see when the lithology cube or fluid cube becomes hot in a way, so that then you are starting to highlight strongly certain features from the amplitudes and weakening some others. So this tool, you can browse through the different ranges of the chi angle and create this type of QC controls based on reference surfaces. So it's easier to estimate the impact of producing the different EEI volumes as a dependency of the chi angle. So this again gives us then the potential group of relative extended elastic impedance cubes, which now we can use for the other part of the workflow. And within the SRC world, we could go first to the seismic net pay. This is important when you are dealing with very thin reservoirs and siliciclastic environments, and so you would like to estimate the impact of tuning in your data. So you start by modeling a tuning wedge based on the frequency content of your data. Could be also an extracted wavelet or an analyzed spectrum from the seismic you have. Then this gives you this average BLA distribution curve. And the next step then, it's about matching this curve with the data. And there are several restrictions or conditions that we need to have in order to apply this method. This method comes or goes back to methodology developed by Pat Connolly and others within BP, and has been widely published in the industry, and it's regarded as one of the standard workflows nowadays, especially for dealing with problems related to tuning. So we have a color inverted elastic impedance volume as input. And then it's important to make a very detailed interpretation of the top and the bottom of the thin anomaly, let's call it like that, because then it is important to estimate the average band limited impedance values between the top and the bottom, which need to be really on the zero crossing. And then by doing this exercise and collecting that, the tool drives you to this process. You can calibrate that also against well data. Then you can estimate the impact of the net pay. So in many cases, you can see that a very maybe potentially large bright spot area coming out of this thin layer is actually not that strong in terms of hydrocarbon content. That a lot of these effects are coming more due to tuning, that amplitudes are summing up in a very strong way. So by reducing the impact of the tuning, you detuning your data, then you can have a more realistic view into the real content, and especially the net to gross aspects of the reservoir hand. So that's in essence the main content of this. Again, let me just reiterate on the fact that all these applications have been already or been described, and in this page I'm just showing you here now. If you want to go and check them, we have our colleagues in England, have been in the UK, have been broadcasting the detailed workflows on all of them, so they exist and they're quite nicely and quite well done. So then the other aspect is, once you have all this, you have, or you're ready now to enter all this data into Odyssey. Odyssey is our, as I mentioned, our flagship inversion application, which actually converts the or inverts the seismic data towards lithophases, towards porosity, towards net to gross. So we're speaking about rock properties here. We don't invert towards acoustic impedance, but actually we use relative acoustic impedance, EEI volumes, to make that that process. So it has been quite helpful in many cases worldwide. So again, all this SRC tool is preparing and conditioning all the data, for example, necessary to run this. Additionally, also, we do have other modules available, like rock physics, to work on that. But again, today, the main intention was to discuss and expose in general the workflow that is around this seismic reservoir characterization workflow. So this finishes my contribution in this webinar, and stating again what SDC SRC is about, so seismic data conditioning and seismic reservoir characterization. It's version 4.4. And with that, I'd like you to thank you again. Again, you're welcome to post any questions you want. We will come back to you. And this, I give the stage back to my colleague Arne, back then in Oslo.
Thank you very much, Gaston. I hope you had a good session going through the presentation with Gaston. As he mentioned, if there are any further questions, feel free to post them on the chat, or we can take them one-to-one. Just contact us on our email addresses. There will be more sessions following this session, so please look at different social medias for information about them. And finally, I would just like to thank everyone for attending this session, and look forward to coming back with new webinars in the near future. Thank you very much, and have a great day or a good afternoon.